told you to send a yearly report, and you just send me a bunch of numbers. These are not real. These are not real numbers.
Yes, boss. Yes. Yeah. Yeah. Okay. You better hurry. The boss wants the real numbers, so let's get into them. First of all, we try to max out the real number and see what happens. And in the documentation, it says it's going to 306. Well, we'll see how that goes. And then we're going to max out the regular numbers the way we usually do. And then we are doing some conversions. We're going to play around with a bunch of different things here and see what happens with those. And then we're going to look at some regular math function that you can do with numbers and see how they work. And there's a bunch of them. So that's all we're going to do today. So let's dive into the result. Looking at this, we can see that even if the documentation says that we're going to 306, we're actually going all the way up to 308. And then we get to infinity. So 1.7 e plus 308 is the highest number. Then you're at infinity. That's really good to know. And I didn't really bother to go in the negative direction, but I guess it's somewhat the same. Maxing out a number takes us to a bunch of nines. And then when we get to the end of the nines, we get back to 0. But it can go negative as well. So it goes from minus a bunch of nines to positive a bunch of nines. So yeah. Conversion to real. Here we can see that when we convert, it's only converting the 17, I think 16 digits. So it only contains 16 digits and a comma because it cuts here at the 7. And when we get past the comma after 15 characters, 14 characters, something like that, we get an unhandled exception error. So it cannot actually convert a number where the decimal point is beyond the 15th digit. And then just converting regular numbers. And we can see that after we get up to these 15 digits, it's actually converting to 1 comma something plus 15. But notice something here. It returns a comma, and it's a dot that we use in the code. And that is because my original settings is set to use a comma instead of a dot notation. So we're going to try out and see what happens if we convert from a comma to a dot or back, or what happens. So here we try to convert some long string with E20, and it just cuts it at our regular 15 characters or 15 numbers, digits. So the E20 doesn't even count. But when the E20 is within these 15 characters, it is actually converted into 1 and the decimal point, and then E plus 28. So as long as we are working within this 15 or 15 number or 16 digits span, it can handle the conversion correctly. So here we try to use a comma when we define a real in the code, but that's just causing a compile error. So yeah, that's fine. Then I try to do a real of a real, because I just suspected that perhaps a real returns a value with a regular comma, but it doesn't. It returns a value with a point. So that worked fine. So then I tried to convert the value that I got back to a string, and then try to convert that back to a real. That didn't help either, because it's not in the string conversion. It's somewhere in the display of this number that it's converting. And then I just took a regular string with a comma and put it in here and made a real out of it. And that also seems to work. So somehow the string realizes that this is a comma and converts it into a dot for the code. So it's feels like a little bit of magic at the moment, but it seems to work fine, and you should not have any problem with it. And now we're trying to convert to a number, and we're taking this long string, and again, it's only looking at the first 15 digits and turning that into a number, just cutting it off. If we take a number with E20 and within the 15 digits, that causes an error that just returns 0 because it's bigger than the regular number, as we saw above here. If we get beyond the bunch of 9s here, it will just return 0. So it's good to know. If we take a number, 4.8E4, we get 48,000. If we turn an integer or a string, we get the same value. So there is a conversion happening automatically within the typecasting functionality. So it turns it into a simpler way of writing this. Then we go to some math functions, and there's a bunch of them. And let's start with the beginning with ABS. It's just a regular apps function that turns all the positive numbers into positive and negative into positive numbers. Easy as that. And then we have a round function, and that does what you expect it to do, and rounds up and down depending on where the decimal value is. You have an exp function where I type 10 and it returns this 22,026. You have exp1, which returns the 2.718. And then you have log values. So what this does is it says we have 10, and then e to the 5, and the 5 is here. So you can write this in this way to make that expression. Then we have the square root function, works just as well as we expected. Then there's this mod function that can return the modular value. But not only that, if you go down here and see, we have a ModAlt that takes the opposite value if it's negative. So if you see, we have 130 is 10, minus 130 is minus 10 for mod. And if you have mod alt, you get 10 on the positive, but on the negative, you get the negative from 60 down 10. So you get to 50. So that could be useful in some cases. Then we have the random function, and you put an integer in here, and it will return everything from 0 up to the value of that integer minus 1. So if you put 2 here, you'll get a value between 0 and 1. If you put in 100, you will get a value from 0 to 99. And then you have your regular Acos, Asin, and Atan, and cosine and tangent functions. And that covers everything that I wanted to mention about real and numbers. You can change between them as long as you stay within these 15 digits. I hope you got something out of this video, and that there was something you haven't thought about previously. Please share your ideas and thoughts in the comments below, and I see you next time. Bye bye.